Alright, on to the next one. Now he says how many Pythagorean triplets are there whose one member is 72. Right? Now I know the Pythagorean triplets. Basically they follow Pythagoras theorem, which is a square plus b square is equal to c square. Now he says whose one member is 72. So maybe the member is say c. So that means I am looking for a square plus b square that is equal to 72 square. Let me look for sum of two squares equal to 72 square. Right? Now 72 square actually turns out to be 5184. Right? You know all the squares from 1 to 100, you know all the squares. You can check whether the sum of squares actually turn out to be equal to 5184. Right? It's not that difficult to check. You have time and you need to check it. Right? But sadly you realize that there are no such numbers. Right? But now the question is, do you think the question is done? No. He says whose one member is 72. 72 can be here or 72 can be either of these. Right? So maybe I can have a square plus 72 square is equal to c square. Maybe I can find a and c which satisfies this equation. Now, how to solve it? Now, obviously I can put 72 square as c square as a square. C square minus a square. Right? Obviously, this is easily factorizable. This is c minus a into c plus a. Right? 72 square, 5184. Now, obviously, these two have to be a natural number, right? Because Pythagorean triplets are for natural numbers. Right? This is a natural number, this is a natural number. Product of two natural numbers I already know. Right? There are hardly any cases for these. Right? Let's see. Either this can be 1 or this can be 5184. Right? This is one case. Or it can be 2 and then this can be 2592. This can be 3 and it can be 864. Right? And this can be 4 and it can be 1296. Right? So on, you will reach up to a point of 72 into 72. Right? Further, you do not need to check because obviously c minus a have to be the lesser of the quantity. If you go further, this will become larger, this will become lesser. So I will not check it. Right? From these, you just need to choose the appropriate option where a and c both are integers, and you will find that there are 12 such pairs. So that means you didn't get any pair or any triplets from here, but from here you got 12. So that is why the answer is 12 Pythagorean triplets. Alright, on to the next one. Now he says write the number of functions from this set to this set, such that whenever I is less than j, less than k, this condition is satisfied as well as this. Right? Now, we know what a function is. Right? Each and every element of this set must be related, in fact, must be uniquely related to element over here. Right? So, if I want to count the number of functions, let me have the arrow diagram. So, first set, second set. 1, 2, 3, and this is 1, 2, 3, 4, 5, 6, 7, 8. Now, he says whenever I is less than j, less than k. Right? As you can see, I, j, k will come from where? This set. Right? So, whenever I less than j, less than k, that means I has to be 1, j has to be 2, and k has to be 3. Because he is talking about these three numbers, right? And they should not be equal to each other, obviously. That means I is equal to 1, j is equal to 2, and k is equal to 3. Whenever this is the case, which is always, f of I as in f of 1 must be greater than f of 2, and the second condition, f of 3 must be greater than f of 2, and the third condition, that 3 less than equal to f of k less than 7. Now mind it, f of k. Now k we are obviously it's f of 3. Now this number can be associated with this, but there is a restriction. Either it can be associated with 3, right? Or it can be 4, or it can be 5, or it can be 6. Do you think it can be 7? The answer is no, obviously, because equality is not there. So that means I have 5 cases and I need to count how many functions are there in each of these cases. Right? Now, first case, when f of 3 is 3, that means 3 is definitely related with 3. Right? Now, that means f of 3 is greater than f of 2. So, 3 is greater than f of 2. Perfect. Now, 3 is greater, or we can say f of 2 is less than 3. Right? So f of 2 might be related with 2 or it might be related with 1. It's very clear, right? Let's see what happens when f of 2 is related with 2. Let's talk about f of 1. Now, how many possibilities does 1 have? Do you think 1 can be associated with 1? No, because then f of 1 will become 1 and f of 2 is obviously 2. So, obviously 1 is not greater than 2. So, f of 1 cannot be 1. Do you think f of 1 can be 2? Then this is 2 greater than 2. Rejected, this also cannot be the case. Right? Now, let's see whether f of 1 can be 3 or not. Right? So, 3 greater than 2. Yes, I can do that. Right? So, 1 can be associated with 3. So, this is my first function. When f of 3 is 3, f of 2 is 2 and f of 1 is 3. First function. Right? Okay. Now, mind it, do you think f of 1 can be associated with 4? The answer is yes. Why? Because 4 would be greater than 2. Satisfying? Right? So, that means I will get another function. Cool. Now, another function. Now, do you think 1 can be associated with 5? There is no restriction there, so yes, it can be associated with 5. Another function. Right? Then 6, another function. Then 7, another function. Then 8, another function. That means in total, in this condition, I am getting 6 functions. Cool? Right. Let's count more. Now, I have exhausted cases for this. Now, let's change f of 2. So, earlier I associated with 2. Now, let me associate 2 with 1. Right? Let's see what values of f of 1 be. Now, do you think 1 can be associated with 1? No, because then f of 1 will become 1 and 1 is not greater than 2. So, f of 1 cannot be associated here. Do you think f of 1 can be associated with 2? The answer is again, no, here we need to change it. This is 1 now. Now, f of 1 is 2, so 2 is greater than 1, so that's absolutely fine. So, maybe I can associate 1 with 2. Do you think I can associate 1 with 3? Another function. 4, another function. 5, another. 6, 7, 8. So, how many? That is 7. Done? Right. Now, obviously, I have exhausted all the cases now. F of 2, I have taken it to be 2. F of 2, I have taken it to be 1. Exhausted? So, that means f of 3 associated with 3 is exhausted. This case is done. Moving on to the next one. Alright. Now, f of 3 is 4. This is fixed. Now, I will fix my f of 2. Right? In fact, yeah, I should write it here. F of 3 greater than f of 2. And made space for myself. Alright, cool. Now, let's see. F of 2, which values can I take? Now, obviously, f of 2 cannot be 4, right? It has to start with 3. Right? Cool. Now, in this case, do you think f of 1 can be 1? No, because then 1 would be greater than 3, which is obviously not the case. Do you think f of 1 can be 2? Again, not satisfied. F of 1 can be 3? Again, not satisfied. F of 1 equal to 4. Do you think satisfied? Yes. One function. F of 1 equal to 5. Another function. 6, 7, 8. 5. Right? Now, next case, where f of 2 is actually equal to 2. Now, let's talk about the various associations of 1. Obviously, 1 cannot be associated here or here. It has to be either 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6. So, that means 6. Done? Done. Now, when f of 2 is 1, I can associate 1 with this. So, that means in total, again, I'm getting how many? 7. Right? Now, I've exhausted this one also. I will move on to this. You will realize that there's a pattern here. 4 plus 5 plus 6 plus 7. Next one would be 3 plus 4 plus 5 plus 6 plus 7. Next one would be 2 plus 3 plus 4 plus 5 plus 6 plus 7. Add all of these because we have counted all the functions. The answer will turn out to be 78. Alright, on to the next one. Now he says let alpha be the real roots of this equation. Okay, alpha be the real roots. Write the sum of all possible values of. How should I say it? The greatest integer function. Isn't alpha. Alright. On to the next one. Now he says let alpha be the real roots of the equation. Write the sum of all possible values of zint of alpha plus 6, where he has defined that zint of alpha as greatest integer less than or equal to alpha. Right? First of all, let me try to find the roots and then we'll figure out about this function. Cool. Now he says you need to solve this equation. X raised by 8 minus x raised by 4 plus 2x square minus 1 equal to 0. Right? I need to solve it. Now, first technique, that is factorization. Now, factorization. Somehow if I can make the factors, my job will be done, even though it is of the degree 8. Now, wait a second. I can see x raised by 4, 2x square, and then 1. X raised by 4, 2x square, and then 1. If I take minus common, I will get this thing. Now, this is indeed a perfect square itself. This is nothing but x square minus 1 whole square. Right? X raised by 8 as it is. Now, this is nothing but a square minus b square type, whose factors I already know. Right? So, let me use it. So, obviously, I can write this as x raised by 4 whole square. Then, obviously, this is squared quantity. So, a square minus b square. So, a plus b. So, x raised by 4 plus x square minus 1 into a minus b. So, x raised by 4 minus x square plus 1 equal to 0. Mind it, I am looking for the real roots. Now, from here, I can treat this as a quartic in x square. I can see that there are no real roots. Right? You can check it. From here, I can solve it. Now, treat this as a quartic in x square. So, write x raised by 4 as x square whole square. Right? Apply the quartic formula. X square will turn out to be minus 1 plus minus root 5 by 2. Right? Mind it, this is x square. So, it's a positive quantity. Right? It cannot be a negative quantity. So, that means minus 1 minus root 5 by 2 is already rejected. The only possible case, that is minus 1 plus root 5 divided by 2. Right? Now, I need to talk about the solution. That means I need to talk about the value of x, not x square. So, from here, I can find it. Right? Approximate value, I'll take it. So, x will either turn out to be 0.8 or it will turn out to be minus 0.8. Substitute the approximate value of root 5 and you will get it. Right? Okay. So, that means alpha can be 0.8 and alpha can be minus 0.8. Mind it, I want all possible values of zint of alpha. That means greatest integer less than or equal to alpha plus 6. This entire thing. So, first of all, let me have this one. Right? Now, 0.8, I want integers less than it. First of all, integers less than it. That means 0. Then minus 1, then minus 2 and so on. He says, I want the greatest integer out of these. That is 0. So, that means zint of alpha is nothing but 0. I want zint of alpha plus 6. That is obviously 6. Right? 0 plus 6. Now, let's come to this one. Now, alpha is, it can be minus 0.8. Now, integers less than it. It can be minus 1, can be minus 2, minus 3 and so on. But I want the greatest integer, greatest of these. That is minus 1. So, zint of alpha is nothing but minus 1. Now, I want zint of alpha plus 6, which is obviously 5. Now, all possible values. I want sum of all possible values. 6 plus 5. That is why the answer is 11. Alright, on to the next one. Now, he says a vessel is filled to its capacity. That means it's entirely filled with pure coconut milk. 9 liters is withdrawn and replaced with an equal amount of water. So, 9 liters of milk have been taken out and 9 liters of water has been put in. Now, he says 9 liters of the mixture is again withdrawn and then replaced with equal amount of water. Right? Okay. Now, he says after these changes, the vessel contains 7.1 liters of pure coconut milk less than it did initially. Find the capacity in liters. Right? So, whatever I need to find out, I will suppose that to be x. Now, mind it, initially the vessel is filled to its capacity, right, with pure coconut milk. So, initially milk, the amount of milk would be equal to the capacity which we have taken to be x liters. So, we have milk x liters, right. Initially there is no water, so 0 liters water. Cool. Now, he says 9 liters have been withdrawn from the vessel. So, 9 liters of milk obviously have been taken out, x minus 9. And it has been replaced with equal amount of water. So, that means I now have 9 liters of water. Right? Till now, we have done this. Now he says 9 liters of the mixture, right? Now there is a mixture. Now since we are going to talk about mixture, let me talk about milk as well as the water, right? If we want to talk about them individually, I will talk about parts of them. How many parts of milk is there? How many milk parts of water is there, right? So if the total capacity of the vessel is X, and I know that we have X minus 9 liters of milk, that means X minus 9 by X part of the vessel, right? That has milk and the remaining one. So that means N divided by X. That means this much part of the capacity of the vessel that has water in it, right? Okay. Now he says 9 liters of mixture is withdrawn, right? So obviously some milk would be taken out of that mixture and some water would be taken out, right? Now I know in each one, right, in the entirety of one, I have this much part of milk, right? Now how much liters I need to withdraw? 9. So in 9, how many parts of milk will be taken out, right? That would be 9 into X minus 9 divided by X. Because in 1, I had this much part, right? In 9, I would have this much part. Now, this much has been taken out, right? Similarly, if I want to talk about this, but in 1, I had this much part of water. Now, in 9, how much water will be there? 9 into 97, right? So, this much water would be taken out. But we do not care about water, so that is why I will just stick to the milk, right? This much milk has been taken out. Out from what? X minus 9. Right? So this is nothing but X minus 9 minus this thing, 9 into X minus 9 by X. Right? Now this is the quantity of water. This is the quantity of milk available now. Now says after this changing, the vessel contains 7.1 liters of milk, less than it did initially. Initially, how much milk was there? X. Now it is this much. He says the difference is 17.1. So this minus this, that is 17.1. Right? In this question, it was just about setting up the equation. Now equation is there. It will be a linear equation. You can easily solve it. Answer will turn out to be 90. Alright. On to the next one. Now he says if this is equal to this, then you need to evaluate this quantity. Right? Now the thing is, somehow I need to generate this quantity. Okay, and I have to start with that. Now obviously the logical step is I'll cross multiply at least, right? So I'll cross multiply and I will get a relation, which is a very nice relation, which will turn out to be 2a into 3a minus x is equal to 25x squared. Right? Because ideally you get this relation square root of 2a into square root of 3a minus x equal to 5. Right? Obviously, I would not want radical sign, even though it is not mentioned in the question, but I am going to square it out. Right? Because since I'm only interested in the value of it. Cool? Alright. Now, the thing is, from here I need to somehow generate this. Now, if I look carefully, this is 625x raised to 4. This is 25x squared. If I want 625x raised to 4, I will want to square it. Right? So, what I'll do is, I'll square these two quantities again. And if I square it up, I will actually get this quantity, 625x raised to 4 plus 24 a cube x minus 36 a raised to 4 minus 4 a square x square plus, no, that's it. This will we get, and this is equal to 0. Now mind is, this entire thing turns out to be 0. Because if this is true, that means this quantity is 0. Right? Now this is 0, that means my answer is 95 by 5, which is obviously 19. Alright. Let's move on to the next one. Now he says for how many positive integers k, so k is a positive integer, do the lines with equations this and this intersect at a point whose coordinates are positive integers. Now I want to find the point of intersection. Obviously point of intersection comes when we take the two equations simultaneously, right? When we solve them simultaneously. Now mind it, k has to be an integer. Also the solutions have to be integers. In fact, they have to be positive integers. all of these, this is a positive integer, positive integer, positive integer, positive integer, positive integer. Right? Now my equation is 9x plus 4y equal to 600, and the other one is kx minus 4y equal to 20. Now what is that one very tempting thing to do over here? Right? Now 4y minus 4y. Obviously I would like to add the equation. So this becomes 9 plus k into x. That is 624. So x turns out to be 624 divided by k plus 9. Right? Mind it that x is a positive integer. That means this have to be an integer. That means 624 have to be completely divisible by k plus 9. Right? Also, k itself is a positive integer. That means k plus 9 is, maybe it is 10, maybe it is 11, maybe it is 12, and so on. Right? So I can just look for the factors or divisors of 624. Mind it, those factors which are greater than 9. Right? So obviously the first factor would be 12. And the next factor, we can write it like this. Yes, the next factor can be 13, then 26, the corresponding values. Now we are talking about 624, factors of 624. Yeah, 12, 13, then we have 16, then 24, and then we can list out. There aren't many factors by the way. But, we can further reduce the problem. Why? Because, look, I have just talked about x. I can talk about y as well. From here, I can write y as 600 minus 9x divided by 4, which is nothing but 150 minus 9x by 4. Now, if this has to be an integer, obviously this is an integer, this has to be an integer. Right? That means x needs to be divisible by 4. X needs to be divisible by 4. X needs to be divisible by 4. Now, this is already divisible by 4. Right? So that means this factor has to be such that my 4 factor doesn't cancel out. So definitely it cannot be a factor like 30. Right? Have to be careful of that. Now we can just list out the factors. So we have 12, 13, 16, 24, and the last factor is obviously 624. We can find out the corresponding value of x. We can find out the corresponding value of y. Right? And there are hardly any cases they just turn out to be 7. Right? That is why there are 7 positive integers k, for which x and y also are positive integers. Alright, on to the next one. Now he says 3 sisters came to the market to sell chickens. One bought 10, another 16, and third 26. They sold a portion of their chickens by noon at the same price. Right? In the afternoon, afraid that not all chickens would be sold, they reduced the price and disposed of the remaining stock, all at the same price. So initially also they had the same price, and after they have reduced the prices, again they have all the same price. At the end of the day, each sister had obtained the same amount of money from the sale, which was rupees 3,500. So first sister, second sister, third sister, all of them got 3,500. Right? Write the number of chickens sold in the forenoon. Right? Forenoon, that means before noon. That means in the morning time. Right? That is what I'm interested in. Now, mind it, there are 3 sisters. 1, 2, 3. This one have bought 10, 16, 26 to sell. Now, initially in the morning time, maybe she sold X, then this Y, and this Z. Right? In total, the first sister had 10. That means in the afternoon time, she will sell the remaining, which is 10 minus X. So remaining 16 minus Y, then 26 minus Z. Right? Now, these are the number of chickens that we are talking about. But I am interested in the money. Right? Each chicken would have some price to it. So initially, maybe the price is M. And in the afternoon time, they had D, because they have reduced the price, that is N. Now you will say, ma'am, you have involved 5 variables. Mind it, these come with lot of restrictions. X can vary from 1 to 10, right? In fact, 1 to 9 only for that matter, right? Y again varies from 1 to 15 for that matter. Z varies from 1 to 25 for that matter, right? So that means these are very less values that we need to check about, For x we just need to check about like 9 values or something like that. That's it. Right? And obviously m and n, they will also be integers only, and that will not too high. Right? Okay. Now let's make the equation. Now for each sister, each sister is getting 3,500. So in the morning time, she sold x chickens at the price of m. So in total that is mx. In the afternoon time, she sold 10 minus x chickens at the price of n. So that means in total that is n into 10 minus x. Right? So money in the morning, money in the afternoon. In addition, I would have this to be 3,500. Right? Similarly, the second equation, that is my plus n into 16 minus y equal to 3,500. Right? And then I can write mz plus n into 26 minus z, that is equal to 3,500. Now I think you know the very next step. Come on, 3,500, 3,500, right? I would want to subtract the equation. Now, since I want x to be involved, because x does have the lesser number of variables, values to check, I will always involve x. So first of all, yeah, I can subtract these two, right? If I subtract these two, I will actually get m minus n into z minus x, same thing, doesn't matter, plus 16n equal to 0. Is that fine? Right? Now, I have involved x, maybe I want to involve y now. You can take any two equations, right, out of these three. It's absolutely fine. So, I will take these two, right? This is nothing but m minus n into z minus y, that is plus 10n, that is equal to 0. Right? From these three equations, I have reduced them to two equations. Right? Obviously, the next logical step would be, what I'll do is, I will shift this to that side, so minus 16n. To that side, so minus 10n. Come on, m minus n, m minus n. I would want to divide the equations, right? Non-zero quantities, you can divide it, it's absolutely fine. So this. So in total, this becomes x minus z by 8, that is equal to y minus z by 5. Why did I write it like this? Right? Now let's see. We know that this is an integer, we know that, right? And if these two have to be equal, here it is 5, here it is 2, here it is 8, here it is 5. That means this need to be an integer in order to be equal. What I'll do is, I will look for the factors of 8 over here. Either it can be 8 or it can be 16 or it can be 24, which will not be possible, we know that, right? Now we know the highest value of x is 9, right? So that means this number, this is x minus something. It has to be less than 9. That means this can only be 8. Right? Now, 8 by 8, that means this has to be 5 only. Done? Now, this have to be 8, that means x have to be 9. That means z have to be 1. Now, z is 1, that means y has to be 6. Right? Done? I think our problem is solved. You will realize you do not have any more solutions. Anyways, if I have one solution, I'll be more than content because the answer is an integer type. He says, write the number of chickens sold in the foremost. So this plus this plus this, which is 16, which is the correct answer. Alright, on to the next one. Now he says the base BC of triangle ABC is divided at D so that BD is equal to 2DC. So let me make the figure side by side. Right? Now A, B, C. Now BC is divided so that BD is equal to twice of DC. Okay. Right? So this is twice of this. So if this is x, this is 2x. Right? So basically I know this ratio 2 is to 1. Maybe I can use that. BD by BC is 2 is to 1. Right? On BC, on the side remote from A, that means not on this side, a semicircle is drawn. Right? So on BC, semicircle, but this side, so maybe this is the one. Right? This is a semicircle, that means BC is the diameter. Now he says through D, draw DE at right angle to BC to cut the semicircle in C. So from here, I need to make a perpendicular to the circle, which means the circle at E. This is 90 degrees. Alright. Now he says from BC cut off a part BP equal to CE. Now CE length is this now. Now he says from BC, from here I need to cut off a part BP which is equal to this one. So I'll measure this and cut it over here. Suppose it turns out to be this one. We know that BP is actually equal to CE. Done? Now he says draw PQ parallel to CA. PQ parallel to CA, where obviously Q is on BA. So this parallel to this, so it is somewhat like this. Yeah. So this parallel to this. Done? Now he says if area of triangle ABC, as in this entire area is 72, you need to find out the area of BCQ. BCQ, this area. Right? Now mind it, since these two are parallel, can I say that this triangle is similar to the big one? Right? Triangle BCQ is similar to triangle BCA. Right? If I know the bigger area, I can find the smaller area, provided I know what? The ratio of the sides. So I should know, maybe I should know BC by BC, maybe I should know BQ by BA, maybe I should know QB by AC. Now my guess is I will get to know BP by BC. So all I'm interested in finding out the BP by BC ratio. Right? Now here, wait a second. He says BP is equal to CE. That means maybe somehow I can find CE by BC. Maybe. We don't know, but maybe. Which is a very peculiar thing. I need to find this by this. In order to find this. Now, what do I know? What I can utilize over here, right? Mind it, I need to use this 90 degree. Mind it, I have to use of this fact that this is a semicircle. Now, semicircle, what is the property? That angle in a semicircle is 90 degree, right? So, maybe if I can join this, right? This is obviously 90 degree. That means BEC is a right triangle and this is actually the odd issue. Maybe I can use that. Also, till now I have not utilized this fact 2 by 1. This is 2 is to 1. So maybe if this length is 2x, this length is x. Right? Okay. What else can I use? Now this is 90, this is 90. We've already proven so many times that DE square is equal to BD into DC. Right? Using similarity we can do that. So that means DE square will turn out to be, this becomes 2x square, so this becomes root 2x. Whatever length I get to know, I'm just writing it down. Right? This is root 2x. Mind it, this is x, this is root 2x. That means CE is nothing but root 3x. I think the problem is done now. Look, CE is nothing but root 3x. BC, the entire thing is 3x. So that means this ratio is 1 by root 3. Right? This ratio is 1 by root 3. That means BP by BC is 1 by root 3. Right? BP by BC. Now, since I know the ratio of corresponding sides, can I find the ratio of the areas of similar triangles? Even if we do not know, within 10 seconds I can derive it. Right? The ratio of the area would be nothing but, I am writing it here, area of BPQ whole divided by area of ABC would be nothing but 1 by root 3 whole square, which is 1 by 3. Now, if this is given to be 72, this will turn out to be 24, which is the answer.